In this course on recording tools, I'm going to spend a little time on the technologies we use for recording and playback. This will include microphones and loudspeakers, which convert sound waves from acoustic to electrical signals and back, and recording systems, analog tape, which is still used for some projects, and digital recording technology, the analog to digital and digital to analog converters in the audio interfaces we use to get sound in and out of our computer's DAWs. As an overview, here's a diagram of the signal flow of a typical recording setup as the sound is passed from one stage to the next. Sound waves originate as acoustic waves, air pressure variations. To record and process these waves, they first have to be converted to electrical waves, voltage variations. A device that converts a sound wave from one physical form to another, acoustic to electric and back, is called a transducer. And the two types of transducers you find in studios are microphones and loudspeakers. To convert an acoustic wave to a varying voltage, naturally, a microphone is used. There are several different methods used for this process, which I'll be covering in the next tutorial. Each imparts slightly different qualities to the sound, making these different types of microphones suitable for different recording applications. Once the sound wave's been converted to a varying voltage, it's ready to be processed and recorded. At this stage, the sound wave is an analog audio signal. And we all know that term, but what it means specifically is that the electrical voltage variations are an exact analog, or copy, of the sound wave's original air pressure variations. There are two ways to record and store the wave, via an analog recording system or a digital one. Analog storage technologies include magnetic tape and vinyl records. Despite the transition to digital processing and storage, both of those analog media are still in use, though certainly not as widely as they once were. Some recordings are distributed on vinyl for a small but dedicated audience who prefer the sound quality of that medium. And some recordings still utilize analog tape, at least at the early stages of the process, for the unique sound quality it imparts to the signal as the recording's going down. I'll go over that briefly in one of the upcoming tutorials. But, of course, the vast majority of recording nowadays is done digitally, and that involves an extra step. The analog signal is further processed by a conversion from an analog varying voltage to a string of binary numbers that describe, in code, the shape of that electrical wave. That conversion is done by an analog to digital converter, the main component of the audio interface you use with your DAW. That string of numbers, a PCM digital audio file, is then stored, most commonly nowadays, on a computer DAW's hard disk. The numbers in the PCM digital wave can then be deliberately changed through processing and mixing in the DAW, creating a new version of the audio wave, or a new audio wave entirely. The final version of the audio is converted back to an analog voltage wave by a digital to analog converter, the other half of the DAW interface. At that point, this electrical wave is sent to another transducer, the loudspeaker, which converts it to acoustic form, air pressure variations, allowing us, finally, to listen to the finished recording. So, in these tutorials, I'll go over transducer technology, the different types of microphone designs, and loudspeakers. I'll do a little bit on the way analog tape does its thing, and why the sound of it is still desirable. And I'll finish up with a brief primer on the ins and outs of digital converters. So let's get started.